Jerusalema ikayalami ilondoloze uhambe nami zungangishilana Jerusalema.
Hello, good day, and welcome to another mathematics tutorial. Okay, so this is module 2 for the sine cosine rule and its applications. Okay, in module 1 we looked very well at the sine and the cosine rule, how and when to apply them. Okay, and this module 2 is just a building block for the module 1. So I'll advise you, if you've not watched module 1, please go and get the video. It's divided into 2 parts. We have the part 1 and the part 2. Okay, get the 2 videos, watch it full, practice everything there. Then whatever we're going to be doing here is going to look very, very easy. Today we're going to be looking at angles of elevation and depression. Okay, I'm going to be teaching you guys from scratch. I will not just assume that you have a basic understanding about it, but I'm going to teach you from scratch. Okay, so if you have zero knowledge about the angle of elevation and depression, this is the video for you. But like I said, please go and get the last video if you are going to benefit fully from this tutorial. Definitely not everything I'm going to be saying here will be related to sine and cosine rule, but there are aspects where we need to solve some questions and we'll be using the sine and the cosine rule. So if you have not watched that video, you might lack in this aspect. Okay, and I won't go back to explain it again because I already did that in the previous video. Now, after saying that, let's get straight to business. Okay, I'm looking at my file from here. The first thing we are going to be looking at is naming right angle triangles. Okay, some people have issues naming or challenges naming a right angle triangle. And what do I have here? We have that a right angle triangle has 3 sides named hypotenuse. We use HYP to denote it, opposite OPP, and adjacent HJ. The hypotenuse, this is the longest side of any right angle triangle. Okay, so I'm going to be using one triangle here to illustrate. If this is a right angle triangle is a triangle in which one angle is equal to 90 degrees. Okay, right angle triangle, one angle in it must be equal to 90 degrees. This is 90 degrees. Okay, so the longest side, this is the longest side here. This is called what? The hypotenuse. Okay, the opposite side, this is the side that is directly opposite to the angle that is given in the triangle. Okay, so if this is where the angle is, if this is where theta is, then this is the opposite side. And then if, let me draw another smaller triangle here. If this is where theta is, then this is going to be the opposite side. Hypotenuse remains constant. Hypotenuse never changes. The longest side. Okay, so it is theta, or the angle that is given, that will determine which side you are going to be using for your opposite. Okay, then the adjacent side. The adjacent means close to. You should first of all understand the meaning of adjacent. Adjacent means something that is close to, close by, a joint. Okay, so the adjacent side is the other side that is close to the given angle in a right angle triangle. Okay, the explanations are already in the notes. Just read the PDF file and you will understand better. But let me just explain what I mean by the other side. Okay, for example, here now this is the adjacent side. Once you know the hypotenuse, this is the hypotenuse here, you know the opposite, this is the opposite, then definitely the third side is what? Is the adjacent side. Okay, why do we call it adjacent? Because it is a side that is close to the given angle. Look at it, shares boundary with that given angle. Look at this is the adjacent side here. Sorry, this is the adjacent side rather. I was doing something else. Let me remove this so that we don't get confused. This is the original stuff. Okay, so this is the hypotenuse, this is the opposite side, and then the third side, this side, is going to be the adjacent. That's a side that is close to, when you look at the definition here, it is close to the given angle. Can you see? There are actually 2 sides that are close to these 2 angles. There are 2 sides that meet to form that given angle. The hypotenuse is always there. It is always there. So it's constant. And then the adjacent side. But the only thing is that we don't always know the adjacent side ahead of time. So you can either get it either when you've already noticed your opposite side. First, you get your opposite side and you know what your adjacent side looks like. Or, if you are more technical, once you know where the hypotenuse is, you just know that the side that encloses, the side that joins with the hypotenuse is going to be the adjacent side to the given angle. Okay, so in this case now, this is hypotenuse. Look at the second triangle. This is hypotenuse, the longest side. This is the opposite side because theta is here. Then definitely this is going to be what? The adjacent side. Can you see this adjacent side encloses with this hypotenuse here to give you what? This angle. So you see that the adjacent side is actually close to this angle. So like I said before, there are two sides that are always close to the angle, the hypotenuse and the adjacent. But the hypotenuse is already special. We already know that. So the second side, the other side, that's what I mean by the other side, that is close to this angle, aside the hypotenuse, is known as what? The adjacent side. Okay, so I think I've done justice on that. These diagrams were just explaining or illustrating what I was trying to say. Okay, now let's move to the next subtopic, trigonometric ratios of a right angle triangle. Now there's trigonometric ratios of the right angle triangle that you need to know about. Okay, it only applies to the right angle triangle. It does not apply to other triangles. And the trigonometric ratios are the SOHCAHTOA. Okay, whatever you need to know is already explained in this PDF resource file. So that's why I would advise you guys to study the resource file very, very well with the video. Okay, the SO is the definition for sine. So it means sine is what? O stands for opposite, H stands for what? Hypotenuse, and A stands for adjacent. Okay, in other places they are just repetitions. AH is the same, adjacent, hypotenuse, opposite, adjacent. Okay, so I won't name everything, I'll just name these three because the rest are repetitions of O, H, and A. So sine, the definition of sine, it says this S here means sine, and this OH means what? Opposite is the ratio of the opposite side to the hypotenuse. Okay, so if you are looking for the sine of an angle, sine theta, it is given as what? The opposite over what? Hypotenuse. The next one we have is CAH, C-A-H. Okay, C here means what? Cosine. So it means the cosine of an angle, say theta, is equal to what? Adjacent over what? Hypotenuse. Okay, so when you see this SOHCAHTOA, the first letters here, these first letters are talking about the trigonometric functions that we are interested in. So S stands for sine, C stands for cosine, and T stands for tangent. T for tangent. Okay, why the next two letters that follow the trigonometric functions are actually their ratios, their respective ratios. So OH here means what? Opposite over hypotenuse. AH here means what? Adjacent over hypotenuse. And then lastly, TOA, we are defining for tan, T for tan. So the tangent of theta, tan of theta is giving us what? You should be able to guess by now. Opposite over adjacent. Okay, so please keep these trigonometric ratios in mind because we're going to be using them very, very well. Now let's move to the next subtopic, solutions to problems involving angles of elevation and depression. So we're going to be looking at angles of elevation and depression here, and like I said, I would not assume that you have a previous knowledge about it. I'm going to be explaining so that you get it once and for all. I took my time to make some illustrative diagrams and I hope it helps. Now look at this diagram. Let's assume someone is standing at this point. Okay, let me draw my own here. Okay. Okay, I forgot to put my 90-degree here, but you should see it in your own resource file. I will edit it. Now, if this is somebody that is standing here, if the person, let me clean this. Okay, so this is somebody standing at this point, standing on the ground. This is the ground. And the person is looking at this point A. Maybe he wants to look at the sun at point A. Let me call this B or base. B for base, like bottom. Okay, now if this person, ordinarily when the person is looking, if the person is looking direct, like straight at this B, this is the horizontal line of sight. The horizontal line of sight is always parallel to the horizon. Horizon is just an imaginary space. It's imaginary space. They are horizontal lines that you imagine in space. Okay, So you can, this is horizon, 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 horizon everywhere. So once you look straight, your eye is actually forming a horizontal line that is what parallel to these horizons. The horizons are just imaginary spaces. Okay? Then if the person looks up, you are going to be looking upwards. So the person is fixing his eye at this point. Okay? So let's call this point C. The angle that is formed when the person is looking from this point, let me change something here. Okay, from this point, the angle that is formed, this is normal when the person is looking forward straight. But when the person now looks up, changes his eye upward, changes his gaze rather upward, there is an angle that is going to be formed. Okay, now that angle is what is known as what? The angle of elevation. You elevate your eyesight. Okay, and that's what I called what D in this place. Okay, and the note is very important. It said, please note, when you look upwards, an angle of elevation is formed. Okay, I don't want to waste time on that. Let's look at the second one, the angle of depression. Angle of depression. Okay, let's look at the diagram that we have here. Okay, so we'll say this is a right angle triangle here. Okay, now let me rub this first. Let me rub this off. Let's assume you are now standing on top of an object. You are standing on top of an object. If you look directly, I've said this before, this is what your horizontal line of sight. I'm just the one calling it horizontal line of sight. It might have another name and we just call it horizontal line, horizon line. But I just want to call it horizontal line of sight. Okay? Horizontal line of sight. That's the line that is formed when you look straight forward. You can read these notes, it explains. Now, if the person is looking down at a can, let's say this is the can here, the person now looks downwards to this can. This is the original line of sight. Now, the angle, when the person is looking downwards, the angle will be coming down. The angle that is formed here, which I called E from your resource file, is known as what? The angle of depression. So note, when you look downwards, an angle of what? Depression is formed. But take note of something else, that the angle of depression is equal to this angle here that I labeled F. Why? Because this line of horizontal line of sight is parallel to the line on the floor or on the ground. Okay? I call this R. I call this P. And I call this Q. This line is parallel to this line. And when you look at this angle here will definitely be alternate to this one. Okay, if you know about parallel lines. And then from parallel lines, we know that what alternate angles are equal. So in other words, E is equal to F. Angle E is equal to F. That's what this thing was trying to explain. So having known that, I think we can quickly jump into our questions. Number 1. The angle of depression of a boat. So I'm going to be using 2 notes, one for my diagram and the other one for my solving, just like I did in the last module. The angle of depression of a boat at sea. The angle of depression of a boat, okay, at sea from the top of a cliff. So let's assume this is the cliff. This is the top of the cliff. The angle of depression of a boat at sea. So the boat is somewhere on the floor. It's somewhere on the ground level anyway. It's on the sea. So let's call this B. B for boat. C for top of cliff. C is representing top. You can use any variable name you like. You can use S, you can use X, you can use Y, whatever. But I will advise that you use something descriptive. The angle of depression from the top of a cliff is 65 degrees. Now, angle of depression, if the person is standing on top of this cliff here, this is the person here, this is the line of sight here, horizontal line of sight. Then, for the person to look down, it means this is normal line of sight. I call this one horizontal line of sight because the person is looking directly, is looking forward. Okay, why I call this one, we just call this one the line of sight. So if I say line of sight, I'm talking of where the person is facing currently, whether the person is facing up or facing down. Okay, that's what I'll be referring to as line of sight. Why horizontal line of sight is constantly when the person is looking forward. Okay, so the line of sight now, it looks downward. So this is the angle of depression that is formed, and it is what? 65 degree. If the boat is 12 meters away from the foot of the cliff, so this is the foot of the cliff. Let me use F to represent foot. And the boat is what? 12 meters away from this. Okay? I might not even use the two notes. I might just use one because here we might not be drawing too much, like in the former model. Calculate the height of the cliff, correct? To three significant figures. Calculate the height of the cliff. So let's call this height H. H is equal to TF. That's the distance between T and F, the length between T and F. If you don't know how to name all these things, please check the former video. We did some explanations there. Okay, so H, the height, is what we're looking for. Okay. Now let's start. Solution. Now you will recall, that from my explanations, when you look here, I said the angle of depression from this point is equal to this angle at this point, because they are what? Alternate angles. So in other words, it means this angle here is also what? 65 degree. Then you will ask yourself a question. I have an angle given and I have a side of the triangle given. Which of the trigonometric ratios should I use? Okay. Now, the side you are looking for should always be in your formula, and the side that is given to you, the corresponding side to the angle that is given to you, should also be in your formula. Okay, so the side that we're looking for now, you check, how does it correspond to this angle? This is the side we're looking for, H or TF. How does it relate to this angle? If you followed what I said earlier, you will see that H is what? An opposite side to this angle 65. So H is opposite side. So in your formula, O should be there. Then you check again. Okay, fine. Which side is given to me? The adjacent side to this angle is given. 12 meters is given. So A should also be in your formula. A should be in your formula. Okay. You can't put hypotenuse. Why? Because you do not know the side of hypotenuse. The side of hypotenuse was not given. So if you put hypotenuse inside your formula, you're going to be having two unknowns. Opposite side is unknown. Hypotenuse is unknown. Please, how will you get the answer? So one side must be known, and then you put the other side that you are looking for. Okay? Good. So which of the trigonometric ratios corresponds to this? It has to be T, TOA. So we're going to be using tan theta. Okay? So now, to find TF or H, well, I'm going to be using TF. So to find TF at this point, okay, I think I'll still need to be dragging this thing to other places. Okay. So this is what we have. -65 here. T, F, H. I'm only naming the important sides here. Okay, so I'm not putting all this one or even this. This is what we need. This is just what we need. Okay, so let's solve. So we want to find this TF at this point. So we use TOA. So it implies that we use the tan ratio. Using the tan ratio, tan theta, as we've explained before, is equal to what? Opposite over what? O for opposite, A for adjacent, over adjacent. So what is theta? Theta is the angle that is given. Theta is 65 degrees, so tan 65 degrees is equal to what? Opposite Opposite is what? This side here. Let me change my. Let me change. So this is the opposite. Sorry. Opposite. That's what? TF divided by what? Adjacent. What's the adjacent? This is the adjacent side here. Okay, and that's equal to what? 12 meters. So TF now is equal to what? You can cross multiply. That'll be equal to what? 12 times tan 65 degree, giving you what? Which is equal to 25.734. Okay, so 25.734. Let me see if we were told to give, correct to 3 significant figures. So our final answer will be what? 25.7 meters to 3 significant figures. Okay, so that answers question 1. It means that what? The height of the tower, or the height of the cliff rather, TH, this height is what? 25.7 meters. Okay, move to number 2. Kenneth is lying on the ground 8 meters away from the foot of a tree. And he observes that the angle of elevation, so as we are reading, we'll be sketching the diagram small, little by little. Kenneth is lying on the ground. So let's say this is Kenneth's position. Okay, and it's 8 meters away from the foot of a tree. So if this is the tree here, Kenneth is here, is 8 meters away from the foot. Let me use F to represent the foot of the tree. Okay. He observes that the angle of elevation of a bed on the top of a tree. Okay, so a bed is here on the top. Angle of elevation, I've told you, an angle of elevation is always formed when you look upwards. So it looks up. Yes, what's the angle of elevation? 64 degrees. What is the height of the tree? So it's the same TF again. We want to get the same TF. Okay, it's 90 degrees here. Okay, so what do we do to get TF? TF is the opposite side, okay? Quite similar to what we did before. To get TF, that's what's the opposite side, okay? And the adjacent is what? The adjacent is what is given. So we're going to be O and A should be featured in our formula, okay? So we using what? The tan. O and A should feature in the formula. T corresponds to isotan. So using the tan ratio. Okay, tan theta is equal to what? Opposite over adjacent, which implies that what's theta? Theta in this case is what? Is 64 degrees. So tan 64 degrees is equal to what? Opposite. What is the opposite? Opposite is what? This is the opposite side, okay? TF over adjacent, 8. So we have TF over what? 8. Cross multiply. You have TF is equal to what? 8 times tan 64 degrees. So TF gives what? 16.4 meters. So 16.4 meters. We're not going to round up to anything, okay? So we just leave the answer like that. Number 3. A ladder of length 4 meters is placed against a vertical wall. So a ladder of length 4 meters is placed against the vertical wall. If this is this is what vertical means, a straight line. Just a straight line, okay? This is what vertical means. Vertical, a line that is drawn like this. Then a ladder is placed against it. So let's assume this is the ladder. You always slant the ladder against the wall, okay? And the length of the ladder is what? 4 meters. So what are we to do? Okay, such that the angle between the ladder and the horizontal ground is 58 degree. Angle between the ladder, this is the ladder, and the horizontal ground, this horizontal, I've told you line of horizons, they're always like this. So this is the horizontal ground. The angle between this ladder and this horizontal ground is given as what? 58.5 degree. Okay, let me write this clearly. 58.5 degree. So what are we to do? A, calculate the distance up the wall the ladder reaches. Okay, so let me call this T for the top, F for the foot of the ladder, or let me use L. So T, L, and let me call this B, the bottom of the bottom of the wall. Okay, sorry, something just crossed my mind now here. Okay, there's no problem. It's fine. TF. Okay, it's fine. Now back to this. Yes, the wall. So this is the top of the wall. Okay, where the ladder reaches. This is the bottom of the wall. I'm using B to represent that. And this is L, the ladder. This is the foot of the ladder. Okay, we're told to do what? To calculate how high the ladder reaches up the top of the wall. So what is this height? Okay, so to get TB we're looking for, this is T and this is B, which is the height. Okay, and now how does TB correspond to this angle that is given? It's an opposite side, so you know that O should be in your formula. Then which side was given to us? You notice that it was the hypotenuse this time that was given to us, the hypotenuse OH. Which of the three ratios corresponds to this S? So we're going to be using the sine ratio. Okay, sine theta is equal to what? Opposite over hypotenuse. Now, what is theta? 58.5 degrees. So sine 58.5 degree is equal to opposite. Opposite is what we're looking for, which is TB, and the hypotenuse is 4 meters. So we have TB over 4. So what is TB? Just cross multiply. We have TB equal to what? 4 times sine 58.5, which is equal to what? 3.41 meters. Give your answers to one decimal place. Which is equal to what? 3.4 meters to 1 dp. And the B part. What does the B part ask us to calculate? The distance between the foot of the ladder and the wall. The distance between the foot of the ladder and the wall. So this is the foot of the ladder, L here, and this is the foot of the wall, B, to represent the bottom or the base of the wall. So we want to get BL. So to get BL, and BL is the what? Is the adjacent side. Now I can, the adjacent side. Hypotenuse, the side that we're looking for is the adjacent side. So definitely A should be in your formula. A. Hypotenuse is given as 4 meters. And also we just solved now for the opposite side as 3.4 meters. So we know hypotenuse and we know opposite. So I can either use OA, TOA, that's tan ratio, or I use CAH or TOA. Because adjacent is what we're looking for. So adjacent should be in your formula. Hypotenuse, I know hypotenuse already, and I know opposite already. So any of these two formulas you use, you're going to be getting the same answer. Okay, but in this case, I think I will just use my tan ratio. Okay, so using the tan ratio, so tan theta opposite over adjacent, tan 58.5 degree equals what? Opposite over adjacent. Opposite is what we're looking for, and the opposite is what? BL. BL. So BL over what? Over the adjacent. Sorry. We're not looking for the opposite. We're looking for the adjacent. Opposite, we've already found opposite as what? 3.4 meters. And then the adjacent is what? BL. Okay, it's because I'm just using one notebook. That's why it's looking somehow. Okay. When you cross multiply, you have what? BL times sine 58.5 degree equals to what? 3.4. Okay, you do your math. BL is equal to what? 3.4 divided by what? Sine 58.5 degree, which is equal to what? 2.083 meters. But we're told to leave our answer to one decimal place, which is equal to what? 2.1 meters to 1 dp. Okay, so that's that about that. Go to number 4. A vertical pole casts a shadow. So this is, I've told you, this is a vertical line. Okay, and this is the pole. It casts a shadow of 20 meter long. Shadow of 20. You know where shadow is always on the ground. Okay, so if this is the top of the what was it called now? What's it called? Of the pole. If this is the top of the pole, this is the foot of the pole. A shadow will always be on the floor. Okay, the shadow that the sun is casting here, I hope it's the sun. Okay, the shadow of this pole, okay, what it casts on the ground is what? 20 meters. We are told that the shadow is 20 meters long. Okay, let me write it clearly. 20 meters. When the altitude of the sun, when the altitude of the sun is 60 degree, altitude is something that is going up. Something that is going up. When you say altitude, just know it's something upward, something that is progressing upward. Okay, and definitely it can't be a depression. It has to be an elevation. When you say altitude, okay, so this place is going to be 60 degree. We can't put it as a depressing angle, because altitude is always looking upward, always going upward. So what next? What is the length of the pole? What is the length of the pole? So we want to get TF. This is the pole. Let me use L for length. Okay. Let me use S for the shadow. This is the length of the shadow. The shadow extends from this place to this point, and it's 20 meters. Okay. So let's get TF, because TF is what? The height of the pole, which is L. To get TF, and it corresponds. How does TF correspond to this angle? It's an opposite side to the angle, so O should be in your formula. Which side was given? A was given the adjacent side. Okay, so it corresponds to tan ratio. We're going to be using the tan ratio. Tan theta equals to what? OPP over ADJ. So tan, what is theta? Theta is 60 degree. The the opposite that we're looking for is TF, and the adjacent is what? 20 meters. Okay, so opposite over adjacent now will be what? TF over what? Adjacent, which is given as 20 meters. So what is tan? This should be tan 60, because theta is 60. So when you cross multiply, you have what? 20 times tan 60 degree equals to what? TF. So therefore, it implies that what? TF is equal to what? 3.4. Sorry, I have 34.64 meters. Were we told to round up? No. So I can leave my answer like this. Number 5. Okay. What do I have in number 5? From the top of a tower, a student of height 1.7 meters measures the angle of depression of a large parcel at 65 degrees. Okay, so this is a bit technical than what we've been doing before. Let's draw. Oh my God. From the top of a tower, a student of height. So let's say this is the tower. This is the top of the tower. And the student is standing. The height of the student is 1.7 meters. Okay? This is the student's head. The student measures the angle of depression of a large parcel at 65 degrees. Let me call this S for student. S for student. Okay. This is the base of the pole. And then let's say the parcel is somewhere around here. The large parcel somewhere around here. Okay, so when the student looks, this is the line of sight to P. Let me join the horizon on the ground. Okay. This is the horizontal line of sight. Then, when the student, what's the angle that is formed? The angle of depression of the large parcel is what? 65 degrees. It means this side is also about 65 degrees. Remember, alternate angles. Okay, so if the parcel is 25 meters from the base of the tower, this is the parcel, this is the base of the tower. The distance separating them is what? 25 meters. What is the height of the tower? Give your answer to one decimal place. Okay, so we want to find this height, which is what? SB. SB. Okay, sorry. No, we're not looking for SB. We're looking for, let me call this one T, the top. T represents the top of the pole. This is the pole here, from B to T. Then the student is standing from here, from S to T. Okay, so we want to get just TB. How do we get TB? To get TB, first let's get SB, which is the total height. Okay, let's get SB. Let me put this thing somewhere around here. Let's get SB, the total height. Once we get the total height, then we'll subtract the student that is standing up from the pole, that 1.7 meters, so that we'll be left with H, which is just TB. Okay, so let's get SB, the total height. Total height. So first we solve for SB. Let me transfer this. Let me transfer this, okay? So we have this. This is the student here. This is the horizontal line of sight, 65 degrees. I think I only need the relevant things here. 65 degrees, 1.7 meters here. This is the top. This is the base. This is what we're looking for. This is the total height, TH. Okay. So let's get SB first. Let's get SB first. SB, how does this side correspond to this angle that is given? It's an opposite side, so you know for sure O should be in your formula. Okay, this side was also given as 25 meters. Now, what this side that is given, how does it correspond to this angle? Is an adjacent side, so I'm going to be using the tan ratio. So tan theta opposite over adjacent, tan 65 degrees equals, let me rub this, tan 65 degrees. What's 65 degrees? Oh, sorry. Tan 65, what's the opposite? This is the opposite side. Here, SB over adjacent, 25 meters. When you cross multiply, you have what? SB equal to what? 25 times tan 65 degrees, which is equal to what? 53.6 meters. Okay, so the total height from this point to this point is what? 53.6 meters. But we are only interested in what? In this point. Okay, not everything, just this point to this point. This is the height of the pole. Okay, and to get that, what do we do? Is the height of the pole. We'll just subtract 1.7 meters from what? From the 53.6 meters. Okay, so to get TB, that will be equal to what? Now you know that TH, the total height is what? The total height TH is what? ST plus this ST here. ST, let me change the color of this thing. This ST plus what? Plus TB. And the total height TH, total height is given as what? 53.6 meters equal to what? ST 1.7 meters plus what? TB, which we are looking for. Okay, so TB now is equal to what? 53.6 meters minus 1.7 meters. So TB, which is the height we are looking for, the height of the pole, is equal to what? 51.9 meters to one decimal place. This is the answer. Okay, so that's that about that. We'll move to the next question, number 6. Bellabo measures the angle of elevation of a building from two different points, P and Q. Okay, so Bellabo is measuring angle of elevation of a building from two different points, P and Q. So if this is P, so I will just do a sketch here. I will do the real diagram the other note. Okay, so I will just quickly rush with this. Bellabo measures the angle of elevation of a building from two different points, P and Q. Let me draw my triangle this way. Let me have some space. But you can draw it any way you want to draw it. We're gonna arrive at the same thing. Okay. At two different points, P and Q. So let's say this is where Bellabo started from. Okay, this is point P. This is the second point, Q. Okay. Let me start this thing from scratch so that we will not say I manipulated something. Okay, actually this is a sketch. But let me explain the sketch very, very well. I was just trying to rush. If this is Bellabo standing at this point, P, and he is observing, oh my god, he measures the angle of elevation of a building from two different points. So if this is the building, this is the top of the building, this is the bottom of the building, then from two different points he's measuring angle of elevation. So let's say this is the first point, so this is where his leg stepped first. Let me just join this point to this point, and let's say this is the second point, Q. Angle of elevation, he looked upward. After the angle of elevation is an upward, it's when you look upward, an angle of elevation is formed. And from this point Q, when he got here, he still looked upward again. That is how the diagram came. I just rushed it the other time, but I want to explain, and I think I've done that already. Okay, from point P and Q, he finds the angle of elevation of the building to be what, 37 and 58 degrees respectively. From this place 37, from this place 58 degrees. If the distance between P and Q is 48 meters, the distance between P and Q is 48 meters here to here. So what are we to do? Calculate the height of the building. So we want to get this height, TB. Okay, so I think that's clear enough. Let me switch and transfer it to my second note. Okay, so we have something like this. This P, Q. This is the height we have to look for, also known as TB. Okay, there's nothing here. It's 37 degree, 48 meters, distance between P and Q. All right. Now, there are a couple of ways I could get this. I can use a couple of ways to solve this to get my height here. Okay. One would be to use the tan ratio. Since H is directly opposite to this side, I can just use, since what we're looking for, H is opposite to this angle, so I can work for this triangle PTB as a whole, the triangle PTB as a whole. Okay, that's the whole of this triangle here. I can work for everything using my SOHCAHTOA tan ratio, but I don't want to use that. I would prefer we use the sine rule. Let me just use the sine rule. Okay, you can solve it any way you want to solve it anyway. Nobody's going to beat you for that. So to get TB, number 6, to get TB from triangle PQT, where is triangle PQT? This is PQ to T. This one I've highlighted in yellow. Okay, angle PQT is equal to 180 degree minus 58 degree, giving me what, 122 degree. PQT, so it's the angle that is formed here. P to Q to T, I'm talking about this angle. This is what, 122 degree. How did I get that? Sum of angles on a straight line. Okay, it's on a straight line, so 180 minus 58 here, get 122. If you don't understand that I named this angle, please check the first video. Okay, so we've gotten that. Then this angle, what is this angle at T? That's PTQ. Angle PTQ is equal to what? 180 degree minus what? 37 degree, 37 here, plus what? This 122 degree. Okay, I'm trying to get this angle. I'm subtracting the sum of these two angles from 180. Why? Because the total sum of angles in a triangle is what? Is 180 degree. Okay, so I get 21 degree as my answer. So here, this is what? 21 degree. Okay, now I want to use the sine rule. What am I trying to do using the sine rule? I just need this side PET or TP. I want to just get this side. Once I get this side, you know, I already know this angle. I will just use the trigonometric ratios to solve. Okay, so instead of going through one way, another way, another way, another way, I'll just use the sine rule once and for all. Okay, so to get PT, that's this line from here to here, using the sine rule. And if you recall from the sine rule, please, if you've not watched the video, please go and get it so that you understand what we're talking about. Okay, this side corresponds to Q here. This side that we're looking for corresponds to Q. So Q should be in my formula. Q over sine Q is equal to, so Q over sine Q is equal to, then which side is completely given? That's which side is given, such that we have the angle and we also have the side. That is T. Okay, T, we have the angle as 21 degree and we have the side as what, 48 meters. Okay, you know, I'm solving from triangle PTQ. I'm solving from triangle PTQ. Okay, to get PT from triangle PTQ. Okay, so it's this triangle I'm working with, PTQ. All right, so T over what? Sine T. So what is my Q? My Q, that's what I'm looking for. Then what is my angle? Sine Q, that's what? Sine 122 degree, equal to what? What is small t? 48 meters, divided by Then what is big T? The angle, 21 degree, sine 21 degree. Please, this is not Greek. Check the first video. So when you cross multiply, you have what? Q sine 21 degree, Q times sine 21 degree, or you write it as Q sine 21 degree. So Q times sine 21 degree equals what? 48 times sine 122 degree. Okay, so I want to solve for Q. Q divide both sides by sine 21 degree. 48 times sine 122 degree divided by what? Sine 21 degree. So Q is equal to what? 113.59 meters, which is the same as our what? As our TP. You know, small q is the same as what? As TP. Okay? So we have that. Now, the next thing we want to find is directly. We want to just get TB directly, or call it H. Okay? So now from triangle, so to get TB, which is our interest. Now from this whole triangle, PTB, from the whole triangle, triangle PTB, we want to get TB now. To get TB, okay, so I can decide to use sine rule, and if I like, I can use SOHCAHTOA. How will I use SOHCAHTOA? The side we're looking for is what? Is opposite. It's an opposite side. O. So O should be in your formula, and the side, we already have a side that is given. We've worked this TB. We worked it together. 113.59 meters. Okay, so I can use the SOHCAHTOA. That, in fact, that would be the easiest thing for me to use. Okay, but let me just use the sine rule, just to broaden your knowledge about the sine rule. Okay, so we want to get TB. Now from sine rule, the side we're going to be looking for now, which is this H, corresponds to what? This angle P here. So we'll call it what? Small p. Call it small p. Okay, so P should be in your formula because that's the side we're looking for. So P over sine P is equal to what? Which side is fully given? This side, we know the angle as what? 90 degree. And we have the small side as what? 113.59 degrees. So we have B over sine B. Input all this now. What is small p? We don't know. That's what we're looking for. P over sine. Sorry about the noise. Okay, so P over what? Sine P equals what? Why am I writing this? Sorry, I was distracted. So small p over what? Sine big P is what? 37 degree equals what? What's B? Small b, that's 113.59 divided by what? Sine 90 degrees. Sine 90 degrees equal to 1. Okay, so when you cross multiply now, this is equal to 1. So you have 1 times P, which is the same thing as P, equals what? 113.59 times sine 37 degree. So P is equal to what? 68.36 meters. Okay, therefore the height TB is equal to what? 68.36 meters. Okay, so that's the answer for that. Let me check if we're told to leave it to any decimal place. No. So that answers that. Like I said, you can use the SOHCAHTOA. I think that would have been faster for us. You can use SOHCAHTOA to obtain the TB. Okay, but I just decided to use the sine rule. Number 7. Ibukun looked out from a window of height 30 meters. So let's see. Ibukun is looking out from a window of height 30 meters. So the height of the window is 30 meters. This is Ibukun I. Okay. So what else do we know? And observed that the angle of depression of the top of a pool, of a flagpole, was 44 degrees. Okay, so she's looking from this height, okay, 30 meters, and then this is, let's assume this is the flagpole here. This is the flagpole here. This is the top of the flagpole. This is the foot of the flagpole. This is Ibukun here. This is the top of the window where Ibukun is, I for Ibukun. Okay, and then this is the base of the window, or the base of where the window is. All right. Now, what was the angle of depression again? 44 degrees. Let me get this clearly. The angle of depression of the top of the flagpole. This is the top. See this point. Let me highlight it clearly. This point, this is the top of the flagpole. Okay, so the line of sight of Ibukun now to this flagpole is something like this. Okay, if the foot of the pole is 25 meters from the foot of the building and on the same horizontal ground, foot of this is 25 meters from this base, the foot of this tower here, 25 meters from the base here, and they are on the same horizontal ground, they are on the same level, on the same ground. What is the distance again? 25 meters. So what are we to do? Find correct the nearest whole number, the angle of depression of the foot of the pole from Ibukun. Okay, this is Ibukun's horizontal line of sight. Angle of depression to this top. Angle of depression to this top is what? 44 degrees. And angle of, now we want to find the angle of depression to the foot. This is the foot. Let me highlight it. This part is the foot. So angle of depression to the foot is something like this. Okay, let me transfer it so that we can walk clearly. This was the window. This is Ibukun. This is the height, 30 meters. This is the base of the window where she's standing. Okay, this is the foot of the flagpole. This is the top of the flagpole. Okay, this is first. This is a line of sight. This one here is 44 degrees. Then we're looking for this angle, let's call it theta, which is the angle of depression to the foot of the tower. Okay, distance here is what? 25 meters. So what do we do? What do we do? Okay, so now see from triangle to get this angle here. Okay, this is, the angle of depression to the foot of the tower. This is the initial angle of depression, which is just to the top. Okay, angle of depression. Sorry about distraction again. Okay, so I want to get this angle here. Yeah, I was saying before, this is the first angle of depression when she looked to the top. Then when she looks down to the down part of the pole, she still continues the angle of depression. So this is the initial angle of depression. This is the final angle of depression. So the whole of this now is going to be equal to this y, alternate angles. Okay, so whatever this angle is, is what this angle is going to be. So we're going to be looking for theta here. Okay, we want to get this theta. Okay, sorry again about that. Now, sorry about all the distractions. Now let's move on. If at this point now we want to get this theta, I've told you that this angle here is equal to this angle here, alternate angle. Okay, now to get this theta here, I can decide to get this side first, if. There are so many ways to kill a bird. It works in mathematics too. Nobody has told you that you should only use one way to solve something. You can solve in various ways, but you should use the one that you are most perfect with, or the one you feel is faster for you. Okay, I can decide to get if first using the Pythagoras theorem. Okay, if is going to be the hypotenuse of triangle IBF. Okay, so when I get this side, I can use the cosine rule. As I said, you should watch the first video if you know what. If I use the cosine rule, I have this side. You can use the cosine rule if two sides are given and an angle that does not correspond to any of the given side is given. Okay, or if the three sides are given. So in this case now, I have 30 centimeter, I have 25 centimeter. If I work this side, I'll have three sides given. Immediately, I can solve for this angle here. Okay, but I think that will be a long journey. Let me just solve. Look at theta. We have theta. Now, theta is the angle. In this case now, we are not looking for a side. We are looking for an angle. But we can still use the SOHCAHTOA. Okay, so the SOHCAHTOA is not just used to calculate sides. You can also use the technique of SOHCAHTOA, if you understand your study formula, to get your what? To get an angle. Okay, so when you check, look at this angle theta. Which sides are given? Two sides are given. And what are the two sides that are given? Opposite side is given. O is given. And what? And let me change this back to black. O is given. And what? This side, BF, which is what? The adjacent side. Okay, so I'm going to be using TOA. Using tan ratio. So I just want you guys to be flexible in all these things. That's why I'm choosing different techniques to work with. Okay, so tan theta, as we all know, is what? The opposite over the hypotenuse. I just keep writing this for clarity's sake. So tan, what is our theta? Theta is theta. We don't know it. Theta is equal to what? What's the opposite? This is the opposite. 30 over, sorry, I was saying hypotenuse. I can hypotenuse. Sorry, it's adjacent. Adjacent is what? 25 meters. Okay, so in this case now we have tan theta as this. You cannot cross multiply into, you are solving for theta. So what is theta? Theta is equal to what? The tan inverse of what? 30 over 25. And when you punch that in your calculator, you're going to be having 50.19 degree, which is equal to what? We're told to do it to the nearest degree. 50 degree to the nearest degree. Okay, so that answers A part. What of B? What were we told to do? From B, we are told to height of the flagpole, the height of the flagpole, the height of the flagpole. Okay, this is the height of the flagpole, TF. TF. This is the height of the flagpole. Okay, to get TF. Okay, let's extend, to make this work easier, I'm going to extend this. Let me use black. I'm going to extend this point here. Let me call it L. Okay, so I'm extending I to L. Sorry, T to L. I'm extending T to L. Okay, so now from triangle ILT, this triangle here, ILT. Let me highlight in yellow. ILT. This triangle, okay, this is 90 degree here. This is 90 degree here. From triangle ILT. Angle LIT, this angle here. LIT, this angle here, is equal to what? 180 degree minus, I could have just said 90 minus 44, but just for clarity's sake, 180 minus 94 plus 44 degree, which is equal to what? 50, sorry, okay, I don't think I need to go through what I'm trying to go through. I wanted to get this angle here, but it's not necessary. We'll just be beating around the bush. Okay, so instead of solving for LIT, we already given the side. If you know, this side is 25 meters. Definitely this side will also be what? 25 meters. Okay, now if this is 25 meters here, we want to get this LT here. We want to get LT. So from triangle ILT now, the side that we're looking for, we have an angle that was already given to us, 44 degree. Okay, 44 degree, this one is already given to us. Let me separate the triangle I'm working with, ILT. Okay, so the side we're looking for, LT, that's the opposite side. Then this side is given as 25, IL, given adjacent side, that's the adjacent side, ADJ is given. Now, so we're going to be using which formula now? We're looking for, so the side we're looking for is opposite, so O should be in my formula, and the adjacent was given, so TOA. Using the tan ratio, okay, we have tan 44 degree equal to opposite over whatever, LT over adjacent, 25, cross multiply, you have LT equals what? 25 times tan 44 degree, so our LT gives us what? 24.14 meters. So this one is what? 24.14 meters. Okay, now if we have that as 24.14 meters, we were told to get what? The height. I solved this one first because it is easier for me. There are different techniques. If you like, you could have solved this directly. There is no problem, and nobody will criticize you for that, but I was just trying to dance around for a while. Okay, so I solved this LT first. Why? Because it gives me a better clue. I know that the total height from here to here, from this point, if you look at this part here, if you look, you can get a clue. I know that this one will also be what? 30 meters. Okay, so now that I have this as 24 LT, 24.14 meters, to just get my TF now, I will subtract this 24.14 from 30. I hope you get that. Good. So let's move. So LT now, or TF, is the height of the pole. TF is height of pole. Okay, and total height is what? LF. I'm just taking my time to explain like a baby, okay, because of some people I wouldn't want some questions to arise after the whole teaching. Please just get it and get it once and for all. Okay, so to get TF now, so TF now is just equal to what? 30, that's the total height, minus what? Total height is LF, and that's 30 meters. Height of pole, we don't know. 30 minus this one that we got, this 24.14 meters, minus 24.14 meters, which is equal to what? 5.86 meters. To the nearest whole number, we're told to calculate the nearest whole number, that's what? Equal to 6 meters to the nearest whole number. So that answers number 7 perfectly. We'll move to number 8. Number 8. From a horizontal distance of 8.5 kilometers, a pilot observes that the angle of depression of the top and base. Okay, so if this is the pilot here, horizontal distance, you know, a pilot is always up above 8.5 meters. A pilot observes that the angle of depression of the top and base of a control tower. This is quite similar to what we saw before. The top and the base of a control tower are what? 30 and 33 degrees respectively. Okay, so from here to here, 30 degrees. Then to the base, this one is what? You know, is viewing from here to here, the top is 30 degrees. Now, to the base, it's just going to be a continuation of what he was doing here. So everything now is going to be about 33 degrees. Please don't get it wrong. Okay? Don't put 30 here and put another 33 here and say 30 plus 33, 63 degrees. No. Here to here is 30 degrees. This small portion is just additional 3 degrees. Okay? So the whole of this, looking from his horizontal line of sight here to this bottom, is 33 degrees. But from the horizontal line of sight to the top is 30 degrees. Okay, so please take note of that. Don't miss that interpretation. Once you get it, I think the question is set. Base of a blah 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 out that respectively. Calculate correct to 3 significant figures the shortest distance between the pilot and the base of the control tower. Okay, shortest distance, pilot here and the base of the control tower. Okay, so this is what we want to look for, PB. Let me transfer that. Let me transfer that. Okay, so we have something like this. A pilot here, this horizontal line of sight, 8.5 meters. That's what we're told from the question. This is the control tower, this is the top, and this is the base or the bottom of the control tower. Angle of depression to the top, angle of depression to the bottom. The whole of this is what? 33 degrees, but here to here is what? 30 degrees. So we want to get PB, the shortest distance between the pilot. Okay, so to get PB, how do we get this? Okay, I think something can give us a clue. Let me extend this downwards. Okay, let me clean it and make it more descriptive. Since it's not part of the diagram initially, let me use something else to represent it. Okay, so this is just an extension. All right, now this angle here, the whole of this angle is going to be equal to what? The whole of this angle, alternate angle. So this one is what? 33 degrees. Something can help us here. This is 8.5 meters. Definitely this is also what's going to be 8.5. Is it meters or kilometers? Kilometers. Okay, All right. Now we want to get PB. This line here. This is 90 here. So how do we do that? We can easily do that. Now the side that we're looking for from triangle P, let me call this F, the foot. Okay. So from this triangle here, from triangle PFB or PBF, the one highlighted in yellow now, from triangle PFB, we want to get PB, this line. We want to get this line here, P to B. Okay, and that PB happens to be what? The hypotenuse of this right angle triangle. Okay, this is the hypotenuse. So we want to get the hypotenuse. So H should be in your formula. Which side is given? The side that is given is an adjacent side. So A should be in the formula. So we're going to be using the cos ratio. So using the cos ratio, the cosine ratio. Cos theta is equal to what? Adjacent over what? The hypotenuse. Okay, so cos 33 degree equal to what? 8.5. That's the adjacent over what? Hypotenuse. We don't know. That's what we're looking for. That's PB. When you cross multiply, you have PB times cos 33 degree equals what? 8.5. So PB is equal to what? 8.5 divided by what? Cos 33 degree. Okay, let me write this clearly. Cos 33 degree. So PB is equal to what? 10.135 km. So 3 significant figures. That will be equal to what? 10.1 kilometer. Please, when you round off an answer, always let us know. Don't just put 10.1. You put your initial answer, and then when you now finish rounding it up, let us know to 3SF, so that we will know that okay, you were told to leave your answer like that. It's more descriptive that way. Then the second part of the question says we should calculate the height of the control tower. This is the control tower. So the height that has to get TB. To get TB, you should know what these two lines mean. Okay. Now to get TB, let's look at triangle. Okay, so now to get TB, let me use another technique. Okay, from triangle PBI to get TB or BT, anyhow, BT or TB. So from this triangle PBT rather, from this triangle, from triangle PBT to get TB. Okay, what is angle PBT? Angle PBT, that's this angle here. You notice it's a perpendicular line. CBF is a perpendicular line. So to get this PBT, I can just subtract 33 degree from 90 degree, and I have 57 degree. This is a perpendicular line. Perpendicular line is always equal to 90 degree. So 33 plus something here will give me 90 degrees. So when I subtract, I have what? 57 degree. So yeah, I have 57 degree. If this 57 degree, what of this angle? What is this angle? I think I know what this angle is. This is what? You know, the whole of this angle of depression is what? 33 degree. But this part alone is what? 30 degree. So it means that this part will just be what? 33 minus 33 degree. So if this is 3 degree, so to get this angle here now, you can use different methods. So you can use sine rule, you can use anything that comes to your mind. Okay, I'm just going through this for just to be more flexible, so that you guys will not have fear when you want to solve anything that comes to your mind. You use. Okay, so angle PTB, that's this angle here, P to T to B, this angle is equal to what? Okay, PTB, that's what? 180 degree, or I can just use 90 minus, okay, 180 degree minus what? 3 degrees, sorry, plus 57 degree, giving me what? 120 degrees. So this angle is what? 120 degree. Okay, so using the sine rule, the side we're looking for, that's TB, it should be in the formula. Okay, and that side corresponds to what? To this P. So small p over sine P equal to which side is given fully, that's the side and the angle is given. This angle is given, angle big T, and this small side is given. We've already worked this is the hypotenuse. We got it as what? 10.1 kilometers. So P over sine P equals what? T over sine T. So what is my, so P is what? TB over what? Sine 3 degree. That's sine P. This is P here. This is sine P here. 3. This is 3 degree. Okay. Equal to what? T, small t. That's the length. 10.1 over what? Sine T here. Sine 120 degree. Please, if you've not looked at the sine video, go and check it out to understand this video fully. So TB times sine 120 degree, if you cross multiply, equals to what? 10.1 times sine 3 degree. So TB is equal to what? 10.1 times sine 3 degree divided by what? Sine 120 degree, which is equal to what? 0.61 kilometer to 3 significant figures. Okay, so the height of the tower, the control tower, was what? 0.61 kilometers. So that's that about that. Let's move straight away to number 9. Number 9. Two boats 70 meters apart and on opposite sides of a lighthouse. 70 meters apart. Two boats. Okay, so let me call this boat A, boat B. If this is the lighthouse, they said they are on opposite sides. So that means one is either on the eastern side and the other one is on the western side, or north and southern side. Okay, but let's say A is on the west, B is on the east. This is the lighthouse. What other information are we given? Sorry. So two boats 70 meters apart. So the distance between this boat and this boat is what? 70 meters. Okay. The angles of elevation of the top of the lighthouse from the two boats. Angles of elevation, that's an angle when you look upwards, are 71.6 degree, 71.6 degree, and 45 degree. Please, when you are naming all these things, make sure that you name them respectively. So if you named F first, put the angle, the first angle that comes, sorry, A, the first angle that comes, put it on A, and if B was the second angle that comes, put it on B. Don't just name anyhow, though you should still get the same answer, but just for convenience sake anyway. So the angles of elevation, blah blah blah. Find the height of the lighthouse. So we want to find this height here. This is the lighthouse, L, the top of the lighthouse here. We want to get this. Let's call this one the foot of the lighthouse, F. Okay, so let's drag this over to our second notebook. Okay, so this is the lighthouse. That's the top of the lighthouse. That's the foot of the lighthouse. This is the first boat A. This is the second boat B. This angle is what, 71.6 degree. This is the height we're told to find, LF, the height. This is what, 45 degree. Okay, so now we can solve using SOHCAHTOA. Yes, definitely we can solve. Okay, I forgot something else. The distance from A to B, the distance between the two boats is what, 70 meters. If I like, I can solve using SOHCAHTOA. Okay, to get the height, I can solve using, yes, my SOHCAHTOA. First of all, I can get this side. I'm using the tan ratio. Okay, after getting it, then I can do some equations like that and like that and like that and like that. But let's just use the cosine rule. Sorry, the sine rule rather. Okay, that one will be more straightforward for us. So let's get angle L first. This angle. Okay, so let's get angle L first. We want to find LF, which is the same thing as HLF, or you call it H, anyone. Okay, so angle L now is equal to what? 180 degree minus what? 71.6 degree plus 45 degree, giving me what? 63.4 degree. I'm using sum of angles in a triangle. This side is given, this angle is given, this angle is given. So the third one will just be 180 minus the sum of these two. Okay, so this is what? 63.4 degree. So using the sine rule, actually, let me get this side first. This side, you know, this is small a. Okay, so A should be my formula. So A over sine A equals to what? Which side and which angle is fully given? This angle is given, its corresponding side is also given. So I will use L over sine L. Though, yeah, L over sine L. So what is my A? A, I don't know. What is my B? Sorry, my sine A, that's sine 71.6 degree, equal to what? L 70. You know, this is L here, the whole of this side, is my small l. Please check the former video if you don't understand what I'm talking about. Sine 63.4, sine L, that's the sine of this angle, 63.4 degree. Okay, when you cross multiply, you have A equals what? 70 times sine 71.6 degree divided by what? Sine 63.4 degree, which gives me what? 74.28 meters, I suppose. That's if it is in meters. 74.28. Okay, so now that I have this side, I have this angle, I can use SOHCAHTOA easily to get this H. If you like, you could have solved for this side, which will correspond to B here, if you like. But I just decided to use this. I see there are so many ways to solve in mathematics. Just know what you are doing. So let's split triangle LBF apart. So look at what I'm splitting now. I want to split this. You know, we have this side now. We have this side and we have this angle. So we can use, and we're looking for what? This side. So we use the SOHCAHTOA. Okay. So from triangle LBF, to get LF, which is our H, to get this LF here, okay, we are given what? What are we given? The angle that we're looking for. This is the angle. The side we're looking for is opposite to the angle. Okay, you are looking for O, so O should be in your formula. And what are we given? We are given the what? h hypotenuse, because we've already solved that. That is our A given hypotenuse, which is equal to what? 74.28. Okay, so which formula are we using? So h should also be in your formula, and this corresponds to the sine formula. So sine theta, using the sine ratio, sine theta is what? Opposite over what? Hypotenuse. What is theta? Theta is 45 degrees, so sine 45 degree is equal to what? Opposite, which is this, LF, or you can use H, anyone, divided by what? The hypotenuse, 74.28. Okay, when you cross multiply, you have LF equal to what? 74.28 times sine 45 degree, giving you what? 52.52 meters. So that is the height of the lighthouse. That's the height of the lighthouse. We're not able to calculate with any significant figure. So I think that ends that. We'll move to number 10, which happens to be the last question. Caris and Neuron have the same eye length, high level. Okay, they have the same eye level height of 1.6 meters, and they stand 20 meters apart on the same straight line and on the same side of a flagpole. Okay, so let's assume this is how this thing is. Look at them. Caris and Neuron, they have the same eye level. Okay, let's start from, if this is Caris here, and this is Neuron here, okay, they have the same eye level. So this is eye level, same eye level, all right, of height 1.6 meters. So the level of their height is what? 1.6 meters. Their eye level is 1.6 meters. They stood 20 meters apart. So the distance between this guy and this guy is what? 20 meters. Okay, so let me use C for Caris, N for Neuron. 20 meters apart on the same side of a flag, on the same side of a flagpole. Okay, so if this is the flagpole, so we know that they are not on opposite sides. If they were on opposite sides, we'll use the technique we used before. That will split here. Maybe Caris will be here, Neuron will be here. So someone is here, the other person is here. But on the same side, it means they are on the same line. Okay, it means if this is the flagpole, then Caris is here, Neuron is here, on the same side, not on opposite direction. Okay, so that's that about that. Then the angle of elevation of the top of the flagpole is 60 degrees from Neuron's eye level and 30 degrees from Caris's eye level. Okay, 60 and 30. Let me use this as Neuron. Let me use this as Caris. I will still draw it very well. Okay, 60 degree, 30 degree angle of elevation. What is the height of the flagpole? Okay, so we're looking for the height of this flagpole. Let's use F to represent this, the flagpole. F for flag. Okay, let's call this B. B for the base or the bottom. All right, let's transfer this. Okay, so from the diagram we have something like this. This is the flagpole. Okay, this is Neuron. Okay, I call this Caris, then I call this Neuron. I changed it. So from this point to this point, we have a 60 degree, and here to here is what, 36 degree. Okay, horizontal eye level is what, 1.6 meters. This 90 degree here, this is F for the flagpole, or you can call it T. Then this is the base or the bottom of the flagpole. Okay, so we want to get this FB, which is the height. Okay, so as solving this, I can use different approaches. Anyone that comes to your mind, you use, and you're going to have the same answer. Okay. Okay. So now let's solve. I can use various methods if I want to. Okay, it's my choice or your choice, whichever one works best for you. But I want to use the sine and the cosine rule, okay, to tackle this question. I will get the side first. Once I'm able to get that side, things become easy for me. So now to get the side, let's first of all get this angle FNC. So from triangle FNC, that's this triangle here, F to N to C, I'm splitting the triangle. Okay, so from triangle FNC, it's looking quite rough. So from this triangle here, and this angle here, this angle FNC here is 120 degree. Okay, that's just 180 degree minus 60 degree. Sum of angles on a straight line, it's on the straight line here. Okay, so I'm subtracting 60 degree to get 120 at this point. Okay, and if I have 120 here, easily I can get this angle F as what, 180 degree minus what, 120 degree plus 36 degree, and that's 30 degree from the question. Okay, and that's equal to what, 30 degrees. So that means this is what, another 30 degree here. Okay, so using the sine rule now, I want to get this FC, the side, it corresponds to this n here, this point n here. So n should be my formula, n over sine n equal to what, which side is fully given? I forgot to include this. We are given the distance between Nero and Caris is what, 20 meters. Okay, so that's how the 20 came. It was here. So this side is given, the angle is also given. So I'm going to be using what, F over what, sine F. N, that's what I'm looking for, over sine. What is my n? That's 120 degree. Equal to what? What is small f? 20 meters. Divided by sine 30 degree. We were told to leave our answer in surd form. Okay, in surd form. So when you cross multiply now, you have what, n times sine 30 degree is equal to what, 20 times sine 120 degree. So n is what, 20 times sine 120 degree divided by what, sine 30 degree. You can start using surd ways to solve this if you like. That's, you look for the equivalence of sine 120 and the equivalence of sine 30, and you solve like that. But I'm just going to use the calculator straight away. You have what, 20 root 3 meters. Okay, so this side here, we've gotten it as what, 20 root 3 meters. I'm not converting to decimal because we're told to leave the answer in surd form. This is a surd notation. Okay, so, but that is not our aim. Our aim is to get what, this part here, FB. Okay, so now to get FB, if you like, you can use the Pythagoras theorem, and if you like, you can use the sine rule again. Okay, if I was going to use the sine rule, I'm going to use this SOHCAHTOA because it's easy for me. Okay, but if you wanted to use the sine rule, you can easily get this other angle. This one will be what, you have 90 here, you have, this is 90, this is 30, then definitely it means that 90 plus 30, the whole of this will be 60. That means this one is another 30 degree. Okay, and then if you are going to use the sine rule, you are going to be looking for this side. Okay, if you use the sine rule, you are going to use, since you are looking for this side, okay, that will be c over sine c, okay, equal to what? Which side is fully given? This side is fully, we know this side already. We've gotten this hypotenuse here, and we know this angle as sine 90 degree. Okay, so that will be what? B over sine B. Okay, you get your FB easily. Okay, but I think this SOHCAHTOA is very cheap for me. Okay, I'm looking for FB from triangle FBC. That's the whole triangle F to B to C. Okay, so from triangle FBC now, this side, this angle, I know this angle quite well. Okay, and this side, I also know this side. Let me highlight in yellow. Okay, I know this side, and this angle, I know the angle from this whole triangle FBC. Okay, so the side I'm looking for now, how does it correspond to this angle? Is the opposite side. So O should be my formula to get FB, which is the same as our H. FB is the same thing as the H. Okay, so O should be my formula. Which side is given? Hypotenuse. H should also be my formula, corresponds to sine. So using the sine ratio, okay, so sine, our theta is 30 degree, is equal to what? Opposite over hypotenuse. What's the opposite? FB over what? The hypotenuse, which is what? 20 root 3 meters. Cross multiply. Okay, sine 30 is equal to, that's half. Okay, sine 30. So it's the same as saying half when you cross multiply. Instead of sine 30 now, instead of sine 30 times 20 root 3, to be half times 20 root 3 equal to what? FB. 2 here 1, 2 here 10. We are leaving the answer in short form. 10 root 3 equal to what? FB. Therefore, the height of the tower is what? 10 root 3 meters. Okay, so that's that about that, and that brings us to the end of the tutorial. And I hope you've been able to grab what you need to grab about the angles of elevation and depression. See you in the next module that talks about bearings and distances. Thank you.
Vietnam.